Hello, we are Group 6, and today we'll be talking about our project looking at movietickets.com. I am Dion Doucette.
I'm Gopaliran.
I'm Nate Hoganson.
I'm Resford Rouser.
We hope you enjoy our presentation, and we'll begin with discussing the background of our project and company focus. Movietickets.com is an online movie ticketing website founded in 2000 by AMC Theaters and Hollywood.com. They were purchased by Fandango Media in October 2017, but they continue to run the website under the movietickets.com brand. Their site contains information and reviews for thousands of films and sells tickets for over 40,000 screens worldwide. After Fandango's acquisition, their only remaining competitor is Atom Tickets. The objective of movietickets.com is to be a one-stop place for people to get information about movies and order tickets for an upcoming show. The purpose of Fandango Media's acquisition of movietickets.com was to remove competition and increase market shares. Movietickets.com is managed separately from Fandango to give their large user base the same advanced online ticketing process they are used to experiencing. They receive revenue through small convenience fees on ticket transactions and banner ads on the website. By providing quality free information on movies and theaters, they funnel in traffic to these revenue sources. To set up the database requirements, we wanted to ensure a user could access movies information, including title, description, cast and crew members, critic and audience reviews, and ratings. The user can also see if a movie is playing near them, can check show times and ticket prices, and finally book a show and pay for the tickets. Next, we'll have Gopal introduce our model.
Thanks, Dion. This is the conceptual model we have built for our website, movietickets.com. We started creating the conceptual model keeping in mind the user trajectory as the user goes through booking the ticket, and ensure that our design of the table is based on how the user will interact with them. Movie, theater, and show table have ternary relationship with each other. User can search movie and then select theater, or user can first search theater and then select movie. Once a user has selected a movie in the theater, then the user can book a show and a seat. We have also including rating table to store the rating of the movie so that user can book show on the basis of the tomato meter or audience score of that movie. Also, you can see there is a cast crew table which store the cast who have acted in that movie. Now we'll move on to implement our relational model using the conceptual model. With a relational model, you will see information flowing in from multiple sources and converging at those ternary relationship. First, you will see towards the top all the movie information going into the movie table. The middle, you will see theater and its information. On the right, you will see the user. As a user finds a movie at a particular theater, it meets at the show playing table. Then the show is booked and the payment is processed. Also, one thing to mention here is show playing table, which stores the information about the theater, movie, and shows, and it shows a ternary relationship we talked about in the previous slide. Now we'll move on to the next slide. So this is our user table. It's pretty simple table that contains all the information about a particular user with user ID as its primary key. It has relationship with book, which is one to many, stating that a user can book many tickets, but booking entry will belong to only one particular user. Next we are going to talk about movie table, cast and crew table. So movie table have multiple relationship with different tables, cast and crew, show, theater, rating. Movie ID is the primary key of the movie table, and other attributes of movie table are release date, description, runtime, gross box, and movie title. There is a movie genre table which contains all the genres of the movie. So each movie can have multiple genre, and with movie ID as the foreign key of movie genre. Cast and crew member. Cast and crew member has many to many relationship with movie table, and role is an attribute of the relationship with the movie. CCID is the primary key, and other attributes are CC name and short bio. Next, we will have Nate go over our next few slides. Thank you.
Thank you, Gopal. So next we'll be going over the ratings and review tables. So the review, we have a supertype with two disjointed subtypes. And the reason for that is because the critic review is going to need a little bit more information than the audience review. See, we'll need the critic name, the publication, the critique, and the link to that critique. Whereas the audience review is pretty straightforward. We just need the review body and the star rating. So that feeds into the super type, which then feeds into the weak entity that is rating, which contains the tomato meter and the audience score, and is a weak entity that feeds from the foreign keys of review ID and movie ID. Next, we have the theater. Now, when we were originally going over theater, we thought it needed to be a little more complicated. We were including the user location inside it. However, we realized that that's something that we don't need to store. And for the purpose of this database, we just need to have the location of the theaters. So that's what we have here: the street, city, state, and zip of the theaters, as well as the theater amenities. You see that with the relations, there is just one theater for many different seats, different movies, and showings of those movies. Next, we have the seat. So for the seat, we have different prices based on different variables. And we also have the seat, which is another super type with two disjointed subtypes. So we have an open seat and a reserved seat entity type. So the reserved seat is going to need much more information. So we see here on the screen an example of what the user would see when looking at this on the web page, that they need to know whether or not the seat is reserved, the row number, and the seat number specifically. Whereas the open seat, all they need to know is if there's seating available to buy a ticket to the movie. Next, we'll have Resford go over the show and booking tables.
Having looked at the tables that hold the lion's share of our data, it's now time to bring it all together. The show table is in the middle of two ternary relationships, the first between movie theater and show, and the second between booking seat and show. To make this work, we needed to turn those ternary relationships into tables of their own, and we labeled them as show book and show playing. They are connected to the show table through the show ID as its primary key and as their foreign keys. And in the show table itself, we also hold the data of show times and show dates that relate to a particular movie at a particular theater, which will then tie into our next table, which is booking. Booking is the goal of movietickets.com. They're in the business of selling seats. And in this table, we collect the booking time, booking date, and we use the foreign ID of user ID and show ID to link the customer's information and the movie information that they selected together. We then have a one-to-one relationship with our final table, and that is the final step in our customer's journey, the payment table. The payment table is a weak entity of the booking table, and it holds all of our payment information. Originally, we had considered breaking it out into three tables, one holding the credit card information, one holding the billing name, and one holding the rest. But for the scope of this project, we decided to keep it all in one table together. And that concludes all the tables in our database. And now we'd like to talk about our data and some sample searches from our database. So we added about 10 to 15 rows of information per table, and we used Mocru to create our data for this project. And then we imported it into an AWS database that we created so that we could all import and query simultaneously. As you can see here, we have two sample searches, the first being a user looking for a specific movie titled Georgia Rule, and they were looking for a specific location, the zip code 51409. And we can see two results were returned, both at the Mayor Carroll Theater and with show dates and start times in the next coming week. We next can see that someone was looking for a movie. They weren't sure which type, but they know they wanted to watch a drama, so they used the genre. And they also were hoping for a good movie, so they were looking for a movie that had a tomato meter review of 80 or above. And we can see the results presented of The Hurricane and Wish Upon a Star. And with the hurricane, we can see the importance of remembering that greater than or equal to versus just greater than. If we only used greater than, the hurricane would not be presented in our return. And that concludes our presentation for movietickets.com. This was an exciting project that brought together all the lessons we learned throughout the course, but also helped us conceptualize the massive amount of data that websites such as this rely on. For movietickets.com to be successful, they need to have an extremely solid and very accurate database in order to feed information from thousands of theaters, millions of reviews, and millions of customers all into one seamless platform. So with that, thank you. We hope you enjoyed our presentation. And if you have any questions, feel free to ask.